So today I want to go over physical and chemical changes. So to start with, physical changes. Anytime we have a change to a substance where we do not change the identity, there are no new substances formed in a physical change. We might change the appearance or the form of that substance, but it is still the exact same substance. And one word that I really want 8th graders to kind of know and use is the word identity. When we do a physical change, the identity of the substance is still the same. So if I tear paper, it's still paper. That identity has not changed at all. So some other examples of physical change, and two that I want to go over is dissolving. If I ever have something like salt dissolving in water, or if I have sugar or lemonade or whatever dissolving in water, that is always a physical change. And hopefully by now it makes sense, because if you think about it, making that salt water is a mixture, and mixtures are created by physical means. So in order to get dissolving, in order to get mixtures, we have to do physical changes. Another one that is almost always confused with 8th graders, and I really hope it doesn't happen, is change in state. So if I melt something, so if I go from ice to water, if I boil something, if I go from liquid to gas, it's still the same identity. That identity has not changed. So water and steam and ice are all the same thing. They just have different states. So a state change, melting, boiling, freezing, those are always physical changes. And I hope that no 8th grader gets that confused. Change in shape, size, so if I crumple paper, if I tear paper, if I add more paper, and those are all volume changes. And then painting a wall or those are all physical changes because the identity is still the same. Whatever I started with is the same stuff that I have now. Whereas a chemical change is the complete opposite, right? So if I have a chemical change, I have a completely new substance. The identity changed in my substance that I started with. And with the new substance comes a whole new set of properties. So if we talk about iron and rust, so iron has its own set of properties. It's got its specific color, it's got a specific hardness, but when I react it with oxygen and it starts to turn into iron oxide, now I get a new color and I get new hardness and I have a whole new set of properties compared to that normal iron. I change the identity. Same thing if we talk about burning. I go from gasoline, and when I burn it, I have a chemical change happening, and I turn into carbon dioxide in water. Completely new identities with new properties. So something new is changed, something new is created in a chemical change. But if we're looking at something, how can we be sure that it's a chemical change and not a physical one? Because sometimes it can get pretty difficult. So these are what I call pieces of evidence. So help us decide whether it's chemical or physical. So the first one is color change. And you have to ask yourself, and this is important, does the color change make sense? Is it what I expected? If I have white liquid or a clear liquid and I add red food coloring, and when I mix it together I get a red result, well, that makes sense, right? We expected that. That makes sense to us. But if in this example I add a clear liquid to a clear liquid and all of a sudden I get a nice pink liquid, well, that doesn't make sense. We should have expected it to stay clear. But since it changed that drastic color or unexpected color change, now that's giving us a clue that it's probably a chemical change happening. Bubbles or fizzing, anytime a gas is formed when I add some stuff together, bubbles, fizzing, that's a good sign that a chemical reaction or chemical change has taken place. Heat, light, sound, these things, if you think about fire, all make sense because fire is always a chemical change. So in fire, heat is produced, light is produced, maybe some sound is given off, and then maybe even an odor. Okay, I don't have this on here, but odor, a change in odor is also a good chance there's a chemical change going on. And the last one I want to go over is what's called a precipitant. This is a little higher up chemistry stuff, but a precipitant, basically all that's saying is anytime I pour a liquid plus a liquid, and then all of a sudden a solid forms at the bottom, that's definitely a chemical change happening. And with chemical changes, they are difficult to reverse, but we can reverse some. I don't want to say that all chemical changes are permanent because we can reverse some. One example your book gives and that I like is that we can take hydrogen and oxygen and we have a chemical change and we create water. But I can reverse that process. So not all chemical changes are impossible to reverse. Well, I hope this was helpful in kind of deciding between chemical and physical changes. Your code word for this one is Jayhawk. So Jayhawks is your code word to make sure that you actually did view this for your studying.